to within plus or minus 1 or 2 degrees Celsius, which is, when you actually look at it in detail, is about as precise as many modern-day meteorological observations are.
When Spicer examined his fossil collection, he discovered a match between those ancient Arctic leaves and leaves found today in southern Alaska, a temperate climate, very different from the barren tundra today. The model indicated that the average annual temperature on the North Slope was about 42 degrees Fahrenheit, 30 degrees warmer than it is there today. But that number is deceptive, because at high latitude, the yearly highs and lows are far apart. So while the dinosaurs would have enjoyed summer temperatures in the 70s, winters were likely cold enough to produce snow and even ice. On the Colville, summer temperatures are now nearly 100 degrees above the frigid lows of late March. The dinosaur mine has been sealed for 5 months. Now it's time to find out if there's anything inside.
Grab a shovel.
This is not what they hoped to find. The portico built by the miners held up, but the eroding cliff has poured in around the edges, nearly burying the entrance. And there's even worse news.
Well, this is sort of bad news here. Looks like we've got impounded water inside the tunnel. Got water flowing out beyond our vapor barrier. So there must be standing water on the other side of this hole.
During the spring thaw, the river rose an incredible 25 feet and flooded the tunnel.
Oh, joy. Dun, 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 dun. The bad news is we have a mess. Yeah.
There is some good news.
Nothing using. It's beautiful. That is fine. We're going to be safe in here. There's no yield at all.
The walls and ceiling are frozen solid. It's like standing inside a refrigerator, cooled by million-year-old permafrost. During the winter excavation, the team didn't have time to explore the fossil bed. And now, because of the flood, the tunnel floor is hidden beneath at least a foot of ice. And there's only one way to get it out. It will take days of brute force labor to clear out the tunnel. The outside temperature may be warm enough for the scientists to work in shirt sleeves. But this is not a hospitable place. The river temperature is barely above freezing, and the Arctic landscape is barren. If they were alive today, herds of dinosaurs could not have survived in a place like this. What was their polar summer like 70 million years ago? That's the question that Steve Hasiotis has set out to answer. He's a paleoichnologist.
That's a beautiful sinusoidal trace.
He studies impressions preserved in rock, which are often the only record left by birds, insects, worms, and other animals too small or delicate to have become fossilized themselves.
These are just basically associated with things like horsehair worms.
Using Alaskan fossils from the late Cretaceous, He's cataloging the insects and other animals present in Alaska to measure the diversity and health of the dinosaur ecosystem.
All right, guys, grab some gear. We do it by looking at the similar kinds of traces and scratches and trail patterns made by animals and environments today. And then we can take that information, look for the similar patterns in the rock record.
Today, he's brought some fossil impressions to a riverbank near Lawrence, Kansas. With the help of his graduate students, he will try to match the trails made in the 70-million-year-old rock to those made just days or hours ago by modern animals.
Great trail right there. Holy smokes. I think these are these mud-loving beetles where the ceilings of them have collapsed. Bird tracks here, and then these worm trails here. This is the association that we're seeing up in the Arctic.
From the modern-day animals on the bank of the Kansas River, a snapshot of a very similar environment in ancient Alaska begins to emerge. And he's sharing his insights with Tony Fiorillo.
On this here, you got about 4 or 5 different trackways here and trails, ones that are slightly larger aquatic earthworms. Totally fantastic hopping trails of a grasshopper or a cricket. And this other thing here is a crawling trail that's reminiscent of a beetle.
So we got worms, beetles, and some sort of cricket-like thing. Does that help fine-tune the environment that these things are in?
This had to be probably in the height of the summer or near the end where it's very warm. There's a high diversity, low-lying water, swampy areas, nice large lake plain or lake margin exposed.
That means a rich ecosystem in the summer, capable of supporting creatures of all sizes, and a much greater diversity of plants and animals than is found in Alaska today.
Picture yourself standing on this lake shoreline. It's warm, sunny. There are herds of duck-billed dinosaurs and other kinds of plant-eating dinosaurs along the lake, eating vegetation like horsetails, ginkgos, the flowering plants.
Patchy, come on!
An abundance of flying insects and crawling insects on the shoreline, in the water. Theropod dinosaurs, large ones like T-Rex, smaller ones probably like Troodon, and they're hunting these plant-eating dinosaurs.
Can I help you find something? No? You sure?
The good times of the year when it was not dark and cool probably would have been very similar to what we now see in
Patchy,
the
are you messing
southeastern
with the
United
Troodons
States.
again?
With lots of conifers, lots of flowering plants. I mean, in fact, the late Cretaceous, except for the dinosaurs, would not have been an unfamiliar environment to us.
Conditions were mild during the long, bright summer days, but the winter would have been much more challenging. Because they're so close to the Earth's axis, the poles, north and south, experience the most dramatic seasonal changes. At the height of summer, when the North Pole is tilted towards the sun, the North Slope enjoys a month of constant daylight. But in the depths of winter, when the North Pole is tilted away from the sun, the North Slope spends 6 weeks each year in near total darkness. The continents continually drift, and because the North Slope used to be even closer to the North Pole 70 million years ago, the extremes were even more pronounced.
The present location of the Liscombe bone bed, that's at a current latitude of about 70 degrees north. At the time the dinosaurs were living, it was closer to 85 degrees north.
Today, the North Slope is 1,500 miles from the North Pole, but 70 million years ago, it was 4 times closer, a mere 350 miles. With 4 months of darkness during the long winter.
Get your own slimy rock. Yeah.
In thin slices of fossilized trees, Bob Spicer sees how the darkness affected the plant-eating dinosaurs' food supply. Under the microscope, individual cells are visible, showing a pattern of growth rings.
The tree rings show that in the summer the trees were very happy. They were growing quite rapidly.
The light-colored cells were produced during the bright summer months.
And as the season progresses, the walls get thicker, the colour goes browner, until at the end of the growing season the cells are really quite small. Then we get no more cells. The tree goes into dormancy.
The summer growing season was long and active, but once winter arrived, everything stopped.
Now what that means is that it was dark and there wasn't a lot to eat.
Don't mind if I do.
For plant eaters, the food supply would be reduced to decaying plants, roots, even bark.
Yeah.
Hard times. But not necessarily for meat eaters.
Return to your home. Nothing
Like
to see here.
Troodon.
Go away.
Troodon may have had an adaptation that would have turned the liability of darkness into a killer's asset.
What an idiot I was.
Tony recently found a fragment of a young Troodon's skull, which shows that the animal had unusually large eyes and an enlarged optic lobe in the brain.
So the brain would be in this cavity right here. We've just caught the beginning of where that brain is enlarged to accommodate the optic region of the brain.
These guys aren't fooling around.
Troodon's enhanced visual system may have allowed it to hunt at night.
Shame on you. Imagine what your
And it's
father
not
Bull
the
does
only
say to that.
species
I
with
don't
those
care.
features. In 1989, Tom Rich named Leelinosaurus, found near the South Pole, another small meat-eater with unusually large eyes.
No reason.
With food scarce, the large herbivores would need to conserve energy.
Come on, move it, big guy.
They would have been
Alex,
torpid,
could you just go away?
sluggish,
I don't want you to see this.
easy prey.
No, Patsy, don't let this happen. Come on. Just get it over. Get me out of my misery. Get up, Patsy! Get it off me! You are not a piece of meat. I am not a piece.
But maybe the plant eaters didn't hang around. Perhaps when the season changed, they struck out in search of better conditions.
Okay, this is
There's even the
Scouser.
suggestion that some of these animals have gone through annual migrations. It's not inconceivable that these huge herds, particularly of the large plant-eating dinosaurs, migrated over huge distances, much like many
Number two,
modern mammals
do not
do
speak
today
to
in
Scouser
search of
without first
forage.
being spoken to.
Migration is an important survival strategy in today's Arctic. As summer ends, caribou herds migrate south to their winter ranges. The distance is about 400 miles as the crow flies. But because the caribou don't travel in a straight line, the journey can stretch to thousands of miles. Dinosaurs would have had an even longer journey. Because the North Slope was much closer to the poles 70 million years ago, to escape the darkness, they would have had to walk 5,000 miles, nearly twice the distance from New York to Los Angeles. According to Tony Fiorillo, some animals wouldn't have been able to make the trek. He's compared the relative size of juvenile